Let's look at the find the mistake questions from the practice final and see how notation helps us to answer them. Negation of 0 less than x less than 5 is an abbreviation. 0 is less than x and x is less than 5. Negating that by De Morgan's law gives the correct answer. X is less than or equal to 0 or x is greater than or equal to 5. P only if Q. Let's make a truth table. Well, P is true only if Q is true, so that's fine. P is true, but Q is false, so that one is bad. P is true only if Q is true. Well, P is not true, so it doesn't matter. This is P implies Q. The only way for this to be false is for Q to be false and P to be true, which is P is true only if Q is true also satisfies. So this was backwards. Definition of subset. To show A is a subset of B, what we want to show is everything in A is also in B. Does not mean that that every x is in both A and in B. So for all x is in A implies x is in B. Either one of these ways can be used to write the definition of subset. Negation with quantifiers. There exists a real number x, so that for all real numbers y, x plus y equals 0, and we want the negation. So for all x, there exists a y where x plus y equals 0. This is saying for all x, for all y, y being a real implies x plus y is not equal to 0. And so it's changing the exist to a for all, making that incorrect. This one looks complicated. If A and B are sets of integers, f is defined on integers, we define a new type of set, f of A. If some set blah is not equal to blah, so let's call this x and call this y for the moment. So x is not equal to y. It's claiming that there exists an x1 in x that is not in y, and there exists an x2 in y that x2 is not in x. But we don't need and here, we need or. Either there's something in the first that's not in the second, or there's something in the second that's not in the first. So that's really the only problem here,